So just a reminder, if you look down below in the description, you'll find links for the index to these meetings. So if you just came on, you don't want to watch the whole thing and find out what's on it, you can look at the index and find out after the fact if you want to watch it or not. And you go back for like 3 years and find stuff we've been talking about. And for instance, today I'm going to be showing my small robot as just an example of how to hook up how I'm going to put a processor on it. And if you go back to the index, you can find where I was building this thing and building the steering and the drive motors and everything for it. So anyway, that's available if anybody wants to go watch that. So for this week, um, occasionally I will say that I want to put encoders on my lawn tractor. So on this vehicle right here, what I did, it's got 3/4 inch axles on the thing. And I found at a surplus store, I found these gears that have, I think it's a 24 pitch gear. And this particular one has a 1/4 inch hole in it. And the ones I had to start with, the two that got put on the Sammy Mini tractor have 3/4 inch holes, and then a hub also on it. So what I did, I just took the wheel off. I just able to push that onto the shaft and twist it on, and it fit nice and snug. So I just pushed that up against the end of the transaxle, and then so I can put the wheel back on. And then I just have, so I've got a gear like this, and then I've got a smaller gear here that goes to a shaft encoder. So just a bracket to hold that onto the thing. And I kept saying, well, I only had the two with the 3/4 inch holes, but I had these laying around that have the 1/4 inch holes. So I kept telling myself that if I drill that out, I'm able to drill it out to 3/4 of an inch and not totally screw everything up. So I tried that. So I took one of these and uh, I reasoned out if I take a step drill, this one's from Harbor Freight, and it's I think it's a $6 drill bit, and the tip on it is a 1/4 inch, and then the shoulder all the way down here is 3/4 inch. So that's the two sizes that I need. So my reasoning was if I start with the gear like this and put it in like that on the drill press and just start going and start drilling down through that, by the time I get down this far into the thing, it will have give me a 3/4 inch hole all the way through the thing. And I wasn't sure about how big a diameter that was, if that I have to cut that off when it's done or not. So anyway, I started with the gear, and here it is after I ran it all the way through, and I've got a 3/4 inch hole through there now. And it turns out that the hubs weren't a full 3/4 inch, because after I got done drilling through, it left that much of it. I just took a box knife and carved that off, and I ended up doing two of them. So I've got the two that I could go put on my lawn tractor if I decide I want to do something before it gets cold out. I could go out and take the wheels off and see if I can put these on there. And the thing is, it's 3/4 of an inch thick, so hopefully that's enough that if I push it on the shaft, it's not gonna wiggle around on there. If it's not, doesn't fit really snug, I could probably put a drop of super glue on it, or I could even put some epoxy on from the side or something to hold it on there. So that's yet one more thing that if I get around to do that, then I would have the same kind of encoders this one has on my lawn tractor. And that way I could use that to either measure speed or measure distance, or you can even measure the heading. There's lots of things you can do, even though you can't trust odometry completely. It still has its uses, and it's not that hard to put on if you happen to have these kind of parts laying around. So that's something else to be put on my list that I might do that one of these days. So last week I was talking about connectors.
Before you move on,
Yeah,
remind me, are those gears mild steel or was that some sort of polycarbonate
it's
stuff?
some kind of plastic, and I don't know if it's might be what they call acetyl or something. I mean, but it looks kind of like an ABS, but it's got more of a I don't know, like more of something mixed in with it. And you can see that these things I think were actually machined. So I don't think they poured these. I think they actually started off with like a flat plate, and you can see the marks are on there, the lathe put on it. So they
Hmm,
probably just indexed it on a lathe or something to cut the teeth, and then I assume they just did from the side, they cut down to so it's thick enough that it had that much of the hub, and then that much of the gear. So as that, as I say, I just found these in a bin at the surplus store, and it looked like, I got the impression that they were probably samples that somebody had gotten from a company,
got
that
it.
needed gears, so they had a bunch of them in their desk. and they just put them there, and I grabbed, I think I got five gears, and 2 of them a 3/4 inch hole, and 3 of them are 1/4 inch hole. And now I've drilled out 2 of them, so I don't have I only have 1/4 inch hole, one left. So then also, any more on that?
Nope.
Okay, so last week I was talking about putting connectors on boards and thinking, well, maybe you could do more of a universal connector type thing. And I'm saying if you just solder header pins down, let me go to this picture here. How do I do that? So if I say this one, and now where'd my pictures go? Where did my pictures go? Oh, they're here.
I'm seeing Slack, just so you know.
Okay, so this is I was saying I held up that board last week. Here, it's right here. I was holding up this board saying this is a thing I built a long time ago, and this particular board right here is the one that was in question. And I was pointing out that over here on the side, it's got all these connectors here that I said I think are SPI connectors, and it looked like there was. I figured they're using 4 pins per channel, and it looked like I think I just said there's 8 across here, so I thought there was 8 SPI channels. And then when I went and looked it up later, it turns out that's not the case, but I'll show you in a second here. So anyway, that's the board itself. And then along here, there's a ribbon cable. There's a 50-pin ribbon cable that plugs into a block of pins and just simply brings it over to this board. So it's just a jumper that takes it over to that board. So then on the back of that board, I've got like 50 pins or something that came across from the other side. And so that was what I was mentioning last time, and I don't remember. I remember what I was saying to come up with more like a universal way to put out pins and stuff to it. You could. I was taking that as an example. So let me say, connect your screen again. So there's a picture of the board. This isn't my board. This was Alan's board, and his does not have a silk screen on it. Mine's got a solder mask. Mine has a nice green solder mask, and it's just like a bare board. That when he bought his, that's what he had. So that's what the board looks like. And then I was saying, I thought this was a Mini Robomind board, and then later I posted that no, this is I said in the video, no, this is actually not a Mini Robomind. Well, it turns out it is, because if you go look at there's still a website for this, even though this was built in like the 80s or 90s. There's still a website, and here's the schematic of the thing. It's got like it's got 5 pages, I guess, and it's showing you all the stuff there. And then here's one of the important things is the board layout. So here you've got the here's the SPI stuff I was talking about down there. Turns out they actually go the other direction. So it's got I think 8 pins across here, and then there's 4 channels worth on there. And so if you've got an 8-pin connector, you can plug it into that and get your wires. And I kept thinking, well, why do you need quite that many wires on it? But if you can look at the schematic here, and you come down, that's the analog. So here is an SPI connector. Zoom in on that. Here. So on the SPI, it's got a power and a ground pin. And then it's got your 4 SPI. It's got the meso, MOSI, clock, and chip select. And then two other IO pins. He calls one IO and he calls one IRQ. So he's got lots of stuff that you might want on your SPI interface, whereas the actual interface only needs the 4 wires right here. So again, if you pick and choose, you wanted to get a 4 connector block, you can plug it out in the middle of that thing and get that stuff. Or you might want the power and ground and then the 4 signal lines. So you've got some flexibility there. But anyway, I was saying last time there seemed to be a lot of SPI connectors, and it turns out there's really not that many. Let's see how to kind of go back here. And then let's go back to this picture. And it turns out I didn't realize that all the fun stuff was actually under that ribbon cable, because on that ribbon cable over here, he's got a complete an 8-pin port coming out of port E, and another 8-pin port is port F, and the TPU port on the back on this Motorola stuff. Back in the day, they had what was called a TPU, which is a time processing unit, I think is what it's called. And it's basically 16 channels of little programmable processors that are built into the thing. And it just simply brings, he brought the 16 channels of that out to this connector here. And then everywhere it shows the green and the red, those are power and ground pins. And then down here is the A to D port. So he's got an 8-channel A to D. That was my hair. It's got 8 pins, and then it's got a power and a ground. I think there's 2 extra pins. It's the reference, the A to D reference pins. So if we look at this, well, here's just looking at what I was just talking about. One of these is this one is the TPU, and this must be the port E and the port F. And I see this one's all IRQs, and this one has all kinds of strange stuff mixed on it. But it it's just saying these are the pins of the processor that's hooked up to. So this isn't quite as intuitive as it could be. But considering, I think at the time he's only selling these for like $25 a board or something, and it turns out they work out for its time, worked out really well. And if I wanted to go back and load all the stuff, I could actually, still use these things. So here's the A to D port where it's got its own A to D chips that are on the board. And of the 8 pins, it turns out there's only 7 of them. So he's got seven channels of A to D, and one of them is just open. And here's the 2 reference pins. And I don't understand this. He says P14 and has power and grounds, but then they seem to be scattered all over the board. So I don't know how he did that. But anyway, I was able to find documentation for that board, and the whole point was, I wanted to show the example that you can pack these pins together, and then it's got those little header blocks. You get the size that you want, put the pins in, and stick them onto any ports or any individual pins you want here. Plus, you could come up with the individual jumpers, which usually they're all over my table here. But just like what they call the DuPont jumpers, you can plug in a single thing. Say if you wanted to pick up this pin on the TPU port, you can just plug into that and then run it to your other device. So that was something I talked about this last week and didn't have this diagram. So I'll just show the diagram here, and I might even put a link up for these also, just for reference, so people can see what we're talking about there. And then I was also saying, if you're going to put, say, header pins on a perf board, and I was saying that, let's turn this off. So if you just take a perf board like this and put header pins on it, you can put them in and line them up just like that thing we were looking at. But then we looked at that other one that was the PWM board, and they had the fancy colored header pins. So they had one row that was red, one row that was black, one row that was yellow. And that way, when you go to plug in your, say, an RC servo, just by looking at the colors, which way it goes. You don't have to get out the board and a magnifying glass and say which pin is power and which one's ground. So you just look at it, you can see the things. So I looked on Amazon, and you can just buy those. And here's, I'm going to want this off anyway. Let me turn off this right now. Background. There. Okay, so if you look at it, they come, I think it's there's green, red, black, blue, yellow, and white. And when I bought them, it had 5 of each color. So there's a total. So there's 6 colors and then 5 of them. So there's a total of 30. And it was come in a bag like this, and it was like $3 or $5 or something for those. So that's another option if you're, you just want to get cute when you're building your thing. You don't want all your pins to be black, so you can't tell where to plug them in. That's an option, and they're, I think, 40 pins long. So they're, put it this way. So they're fairly long. And here's, for instance, on the board here. That's just how they fit on the board. That's actually upside down, but that just gives you an idea what to put in the direction. So it's actually a little longer than the board, but that, by looking at that one that was the PWM board, that gives you the idea that yes, you can do that yourself. Just go out and buy the header pins and put the equipment ones on for whatever you're trying to do. And let's see anything else on connectors. One of the things I was going to say is that looking at a board like this, this is that F401 STM Micro F401 board, and it's when you buy them, it doesn't have the pins soldered in, but it comes with, you know, in the bag, it's got the pins for you to solder on. And then I've got one here that I have soldered pins on. This one I was actually using. So you've got the option if you just want to solder wires on. Because I went back through the ROS agriculture stuff. At one point, Matt had his plastic box that he was using on his lawn tractor. And first of all, everybody noticed it was too small for what he was trying to do. But inside of the box, he had uh, um, a teensy, the Teensy 3.2, and he just had wires soldered on it. So he didn't have pins or anything. He just simply brought in individual wires and soldered to it. So he at one point he held it up and he had a bunch of wires coming off this way and a bunch of wires coming off this way. And then I assume he just threw that inside the box. Then when he was done, he didn't really have any fancy mechanical mounting or anything. And there's pros and cons to that because number one, it's quick and easy. You just take a wire. Oh, I want that wire. You put it on, you solder it, and away you go. But keep in mind, if you ever have a problem with this board, if you hook up the power backwards, you hook up too high a voltage, or you do something funny with one of the pins and you destroy the board, now you have to go through, you have to cut all the wires and solder them onto a new board. And so I think if I were going to do that, I'd start with the two boards side by side and go to this wire, cut it, and put it on the other board and solder it, and take the next one, cut it, and just move them, just do them one at a time till you get down all whatever you had on this side, and then go over and do the same thing on this side. So you just, you know, cut them one at a time and stick them in the next one and solder them down. But I'm pretty sure you might decide up front, I'm just going to solder wires on, and after you blow it up, you think, okay, I'll move all the wires to another one. But I'm guessing you're not going to do that a third time, so you might want to think harder about, you know, taking your board and solder the pins on like this, so that you can plug those into put some header strips on a piece of perf board, and then plug it into that. So that way, if this goes bad, you just pop it out and pop a brand new one in, and reprogram it and ready to go. So that's that's just something you have to play with and decide which way you want to go on that. So back to the story about Matt's box. He had a box about, I don't know, maybe 8 inches by 8 inches, and maybe, I don't know, 5 or 6 inches tall. And in that box, he had a teensy 3.2 that was kind of thrown in there. He had a Raspberry Pi. He had like a four channel relay board. He had a one of those like automotive fuse blocks. And what else did he have in there? He had some other stuff there. He never gave a real good close up because if you're watching the recordings, you can see I've got the screen set to full size. But you know, when you do like this, you go to gallery mode. See the stuff I was watching had four little images on the screen, and then he'd sit here holding stuff up. So every time you add more stuff to the screen, everything gets smaller and it's harder to see. But anyway, I went through it. I found it where he finally held it up. Says, "Oh yeah, I've got my little teensy board here and just have wires." So it's basically just a rat's nest crammed into a box, and that um, it showed the concept of it, but I would have liked to have it zoomed in a lot more so we could have seen exactly, you know, how many wires he had soldered to that and what you can do with those. So I found that out on Rice Agriculture, and I went through the index to find that. I was very early on, and it said something about Al asked Matt how is he coming on his project, and then on my index it said something about here's his box, here's the stuff that's in it, and then the bottom says everybody's pointing out his box is too small. And that was the big joke because everybody knew his box was too small. So that was that was the story about the connectors we talked about last time, and the fact you could, if you wanted to, you could solder, you know, just solder wires on directly, and that's got pros and cons, or you can do it. So the one I'll talk about this time. Any questions on any of that?
I was curious, what was the vintage of the board that you first showed, the Robomind's board?
Uh,
When was that originally designed, would you guess?
I think it was in '80s or '90s. Let's see if I do.
I mean, it's just like there's a serious computer engineer that put all that together.
Yes, and also the fact that what impressed me the most was he put a lot of thought in where to put those pins and how to put them on and how to hook everything up, and so that was, you know, that was back in the old days, the early days. And I was gonna say So last week I was thinking, well, maybe that's not a Mini Robomind. Maybe it's actually a bot board too. And I thought, wow, how am I ever going to find that? Well, it turns out there's one laying right here by my feet. And bot board two looks like this. And this board has a Motorola 68. Can I read that? 68 HC11, I think is what that is. That's just one of the Motorola chips. And it had, I think it's the big RAM chip over here. And maybe underneath there's some kind of a flash memory soldered on. But anyway, this one, it turns out this was not a good example of all those pins, because if you look on this side here, there's right here, there's some header pins soldered in, and see they're not really close together, and I can't remember. These over here were 4-pin connectors, and I don't remember right offhand what those were for. But anyway, this is the board that I thought it might have been, but it turns out no, it's not this board, but it's another thing that from days gone by. This is about the same vintage as the one that fancier board that we're looking at.
Impressive people put that together.
Yeah, and that's the bot board too. So the bot board one was just a little tiny board that had basically one of those chips soldered on it, and I just some connectors at that point. But I think I found a picture of that. The connectors weren't any more densely populated, so they didn't show the thing that I was talking about with the people putting a lot of thought into the connectors and where to put them and how to line them up and so forth. So I think that pretty much ends that, and then I'll just move on to the next thing if there's no more questions.
Nope.
So I'll switch to this image. So this is the small robot that if you go back through our index and look for small robot, I was talking about building the steering on this thing, and talking about building the frame, which is just some plywood bolted together. And on the back, I've got these 2 motors that came off my green robot. So it's got a motor and a belt drive to each wheel. And my thought was I wanted to experiment and say, if I've got 2 drive motors, do I have to drive them in series or drive them in parallel, or do I put a separate power driver on each one, or what's the right concept? So anyway, I got this all put together, and on the meetings I was saying, well, okay, I've got it all put together to this point right now, and if you ignore the stuff on the perf board here, is basically that's how far I'd gotten, where I've got the motors hooked up in the back here, and coming off each motor. Each motor has a 4-wire cable coming off for the encoders, and it originally had the 2 power wires connected. This is a 6-pin connector, and it had the 2 power wires, but I cut those off, so it's basically 4 wires on a 6-pin connector now. And they're 10th inch, so they'll plug into header strips. So if I come over to this perf board and solder down connectors across here, I can now plug the encoders into that board. And here's the other encoder. So I got the two encoder cables, and those have to plug into that board. And then it's a single channel, I think it's a single channel 10 amp Cytron driver board, and it's got a 3-pin interface here. So I just have to run wires from here to a set of header pins here. And by hooking that up, that gives me the motor control. So I can now, send PWM and direction to this board and make the motors run forwards or backwards. And I got the two encoder cables here, so I can keep track of the motors, how far they've gone and how fast they're turning and that kind of stuff. And then also this one has it's got the RC servo on the front. It's got one of the giant RC servos, and this just happens to be a RC extension cable. And right now it's plugged into one of those little boxes. So if I power it up and just turn this knob, then the steering moves back and forth. So if I take off this, a little adapter that's like a female to female. So then if I just put header pins on the board and plug that in, and then directly control the position of the steering servo at that point. And the other thing I was going to do was this particular RC servo has the position feedback pin. There's an output pin that tells you, it gives you the voltage from the internal potentiometer. So if you hook up to that, you can read that voltage and put that into your processor, which it turns out I don't think I can hook up directly, because either fortunately or unfortunately, they put a 10K resistor in series with that pin on the board, which means now you have to worry about if you load that down, you're going to have the wrong you're gonna be generating the wrong signals. You're gonna load it down and you won't get the accurate voltage. So where did it go? Oh, here it is right here. So I've got this little perf board, and you can buy these various places. You can go on Amazon or whatever. You get a package of like 4 or 5 boards of all different sizes. And so I was going to take one of these and put an 8-pin op amp on this board and just mount it. Let's see, kind of. Anyway, this piece, horizontal piece of aluminum, I was going to bolt it to the side of that, and that way it'll give me a place to mount it. And I just have to hook like 4 or 5 wires from that up to my servo. So the pin, the analog feedback pin coming out of the servo will go through this op amp just to buffer it. And that will give me, it'll be a 1-to-1 signal. So the incoming signal is 0 to 5 volts off that pot. And then I will still have 0 to 5 volts out, but it'll be a low impedance output. So I don't have that 10K resistor in series. And then what I can do, I can run that, run the 0 to 5 volts up to here, and then put a voltage divider on this board to convert that to 0 to 3.3 volts, and just hook it up to whatever analog pin I want. So that's just a matter of, again, just sitting down and doing this to get by with that. And the only other thing I can think of that I was going to do in order to make this actually drivable and to experiment, I've got a board that's this size. This is actually just another processor board. There's a board this size that has that LoRa radio on it. And it's the original ones that I bought when I started doing my other stuff, and decided that number one, it wouldn't work on my main robot because I needed a CAN interface. And on the remote end, it turns out it doesn't have enough IO pins to hook up everything I want. So anyway, I probably have 2 extras of those laying around. And so if I put one on here, it's about the same size, so I can stick it on this board and just run a UART interface from here to here and be able to control it that way. I guess the other thing is, then coming out of that remote control receiver, I need a relay for my e-stop stuff. So somewhere I'll have to bolt a relay on this thing to control the power going to the drive motors and possibly to the servo on the front. And I in my haste, I thought, oh, I'll just put everything on top. See, these are held down with like wood screws right now. So I've got a piece of perf board there and a motor driver there. And it turns out now I can't lay anything on top. I can't put a laptop on here or anything else. So I really should screw these onto like a piece of plastic and then put them inside the thing down here. There's a hole down here. So if you look at the side here, so you can see how tall this is. It's about 5 inches piece of wood coming up. So there's a big hole inside where I could put, say, batteries, and the board that holds these 2 things could go down inside there also. So it's just a matter of, I'm just pointing out that, I got to the point, I was too lazy to do anything with it. Well, now I'm back to the point where here's the perf board that was already mounted on there. I just have to mount down my processor, mount down my remote control, and put a bunch of connectors here to plug everything into. So I thought this would be like a case study on, I got it this far, and now I got to get all the stuff hooked up to my actual processor board over here. And other things that come up, like the fact I say I'm going to have to put a voltage divider for the signal come from the RC servo. I'm going to buffer it at the RC servo, and then up on this board I'll put a voltage divider. I could put that down on the little board also. I'll have to give that some thought to decide where to do that. And other things that might come up, I could figure out, coming from here, the signal that's, well, the signal that drives the RC servo would be coming up on this cable. I could figure out how to put opto isolators in between there, and number one, see, can I get a fast enough signal and get that to work? And then in a big industrial environment, I might even want to opto isolate from this board over to the power driver here. So that's something I can think about, and that's probably something I can just put that in series. So I just unplug the wires and plug my little module in between and hook it back up. So it's, I can either optically isolate it or not. But that's something else that might be worth researching and experimenting with to see if that kind of stuff works. And the main reason on opto isolation is that way you can isolate all the grounds, because somebody says, oh, you should always have a single point ground on your system, run all your grounds back to your main source, in this case a battery. But it turns out this board, it's got here's the power coming in, the ground lead here is tied to the logic ground here. And in the RC servo, it's got the where's that wire hanging out? Well, I'm just wasting time now. No, there it is. So coming off the RC servo, it's got the power leads that run it. But it turns out the ground here is tied to the logic ground on the RC servo. So that's the second place where you get your grounds tied together. And if I put in, you know, some kind of switching converter to get power here, it's probably going to tie the grounds together. So if you you get too many grounds tied together and you get ground loops and you get all kinds of problems. So it's just a matter of if you can put optical isolators, say between this board and this board, then the grounds are not tied together. So the ground on this board goes back to the battery, the ground on this board goes back to the battery, and the ground on the RC servo goes back to the battery, and none of them are tied together anywhere else. So that's something that somebody should research one of these days, but I probably won't do that to start with. This is small enough and low enough power stuff that it probably won't generate enough noise to be a problem, but it would still be a convenient place to experiment with all that stuff. So that's what I've been thinking about and playing with. Any questions on that?
You have two boards sitting there next to your perf board. Are you planning on using both of them or just one of them?
Well, this board will be the actual processor to run the thing, and this board will actually be the remote control receiver board.
Ah, okay, that's why it's sitting there.
So it'll have both of those boards on there, and that essentially then all the electronics will be on this board, and then here's the power driver, and then the RC servo's up there. So that's pretty much how the thing's gonna be laid out. So, and they'll have to experiment to see, do I want to run these two motors in series, or do I run them in parallel, or do I want to put a separate power driver for each one? And there's all kinds of things. I might be able to say run the motors in parallel and put a resistor in series with each one. So as one motor wants to slow down because you're turning, it allows you to overdrive the power that's coming in. So that's just more things to experiment with and see what's actually required there.
You may have said it and I missed it. Have you chosen an opto isolator?
I've got various ones that I bought. A long time ago, I found ones they called them communication grade opto isolators, and they work great. You can push like 20 megabits per second through the things, but you just get the little cheap ones, and they might be limited to like 4K hertz or something. So you have to be careful with those. If you're trying to run a PWM signal through it, and your PWM is running at 20K hertz, but your opto isolator only allows 4K hertz, it rounds off all the signals and it doesn't work the way you want it to. But the ones I bought I bought some on eBay, or I think I bought them on Amazon, and they claim to be 8K hertz or 40K hertz or something. And it's one of those things where the chip says one thing, but depending when they put it on the board with the resistors, that affects the speed of it. So that's something else I'll just have to experiment with and see if I can get by with those. Because those are really cheap and they're small. But the other ones that are the like the communication grade ones, those are like $5 a piece or something. But boy, you can push anything you want through those, and they work great. So that's something to be experimented with.
Yeah, that's not something that I've had to. I probably should have dealt with it, but I haven't dealt with it yet. So interesting to see how you come out. The
And
last
then,
thing I was going to mention, I'm in my next iteration of mounting. I'm going to mount vertical um, and put stuff sort of on the outside of the tractor so I can get to it um, instead of everything sort of horizontal. But I've got a little bit more real estate to deal with maybe than you have.
on my green robot, let's see, wrong camera. We'll do that. Camera. So on my green robot, that's this thing I was just showing, the processor board. This was actually mounted, I think, like this, and this was mounted up to this up against the side of the thing, so you could see this is what you would see from the outside. So that would be exposed, and that was just mounted to one side, and the other side had, I can't remember what was on the other side. Then I had some like PC speakers kind of on there too, and if I do a little digging, I can probably find a picture that's mounted on there. But yeah, at one point I was doing that. I just thought, okay, I forgot vertical flat spots. I made this whole bracket that it just simply has in the corners. There's a hole in each corner, and I just put screws, so the whole thing I can screw it on there, And when I want to work on anything, I take the screws out and just have the whole module like that hanging out. So it, this I think was the power input. It's just like a coaxial power jack, and then there's a green LED just show your power's on. On the back of this, that's actually I think a voltage regulator screwed to the frame there just for a heat sink. And this was probably a reset button. It's one of those guarded buttons, shielded, what do you call those? And this was some kind of a like serial adapter. Again, back in the day, that's just how you do serial stuff. This is, an a RS-232 serial coming in and then converted to a logic level to talk to the board over here. And when you bought this board, you can either buy it with the RS-232 converter on it or just the logic level. And I bought the logic level one and had this external board here hooked up to it. But yeah, that works out well. And also, if you're thinking about it, you can mount it and have this like on a hinge so it swings out like
That'd be cool.
that
What's that black material on the back face of that?
just just this that's just piece
Yeah,
of some kind of plastic that was like maybe ABS plastic or something that I just need something flat to tie it all together. And I could have used like printed circuit board, or I could have used aluminum or some kind of plastic. And this is something I happen to have, and this stuff drills well, and it's fairly stiff, and it worked out. Yeah, and like everything else, I kind of pieced stuff together as I needed it, and that's what turned out on that.
nice.
So I think that's all I have to say.
Well, I'll just sort of start with a layout conversation. This is my Miro board, and I was going down the path of thinking through, okay, what's the next iteration of my board going to look like? And imagine a piece of wood on the side of the tractor, similar to what you just described. And I've only gotten a few pieces laid out here, but I'm thinking instead of a laptop to use an RPi, and I'm thinking of instead of the ESP32 TTGO with LoRa and LED, no LED built in, just to go with the new Teensy. And so this would be the low level controller, and the RPi would be the ROS handler. This, as you likely recognize, is the Citron motor controller. And now that I think about it, I don't know if there's any I have those other motor controllers that they use. I can't put my hands on them. The ones that Ag Open GPS use are physically smaller, and they handle 30 amp. I don't know if I get any benefit from using the Citron deal or not, but so anyway, that's one of the things that I was working through. And in that thought process, I was thinking about the ODOM data from the left and right wheel, and we sort of got options around that. And since the Teensy is such a powerful board, I was thinking I would, instead of the rotational sensors that I have where it's got another board, that I would just use, two of these and wire them using your connector conversation. There would be some sort of plugs up here, but driving all of that from that board. So that was sort of some thinking that I had, and that led me to spend more time reminding myself what those induction sensors were all about. So I had sort of went back through and said, hey, do I remember how these things work? So I took a Teensy that I had lying around, and can't really see it, but put a voltage divider on, put in 12 volts, and got that to work all with, well, I ended up using, I'll just show you the VS Code. Um, I got this all VS Code loaded and Platform IO loaded and programmed the Teensy using Platform IO, which is, again, it's reminding yourself how to do all of this stuff. And yeah, I got that to work. I did have a frustrating point figuring out a voltage divider. It's sort of like, well, come on now, this can't be hard. And but I was following multiple instructions, and for some reason I had to switch the resistors around in order to get it to behave correctly. And I don't know if it's just I had a bad example to follow or the instructions weren't right or whatever. But anyway, I did end up getting it to work, and with those resistor sizes and with that variability of power, because I was using my power supply, so I could adjust that to make sure that I was going to get a high and low on the teensy. So it all worked out in the end. And so let's see, what else was I going to mention? Oh yeah, and that sort of that same process. I'm thinking back to my thinking through my next iteration of boards. How am I going to control the throttle and I'm sorry, not the throttle, the hydrostatic transmission. And I was thinking I'm going to use a linear actuator. And so these guys, Polulu, have this controller that I'm reasonably familiar with. And so I was thinking I would go down the path of connecting this to the Teensy again. So I'd have steering motor controlled by this, the hydrostatic transmission a la speed controlled by that. And so that's my current thinking on my next iteration of electronics board. And then I'd have my battery mounted over here and a power distribution mounted up here so I could get to the fuses and whatnot when not if I blow a fuse. So that's a little bit more of a simple design. And that's about as far as I've gotten. I mentioned briefly last week that I was going to build a NAS drive, and my 2 terabyte PCIe boards drives showed up, so I don't have my RPi. So when that comes in, I'll spend more time on that. And yeah, I think that's about it. I'm turning around because I've got a battery. That blue thing is a lithium battery that I've been putzing around with, and haven't done any more on that, but it's still there working.
Back to
And
back to your concept of vertical panels. Another thing you can do is on top of your board or whatever you're using, put some standoffs and then like screw a piece of plastic to it. That way you give you a guard over it so you don't bang up against it or don't, you know, don't have wires accidentally bounce in there. Or you could even put hinges on that so it opens like a door so you can open it to get to the stuff. And then I suppose have that follow along to your desktop when you're if you take the whole thing off, or you could have it so you take the plastic off and just lay it aside, and then just take your board and put it on your desk when you want to work on it.
Yeah, I sort of like the door idea because, I want it to be weatherproof and able to withstand the wind if I trailer the tractor someplace. So yeah, I'm definitely going to save space on the outer edges for some sort of protection. That's a good thought.
And just things like that come up as you play around with this stuff. You think, oh yeah, I could do that. I could put a cover over it so it just protects it a little more.
I guess the simple thing would be have a frame around it and mount plexiglass on the top of it, but we'll see how that goes. And on the induction sensors versus your rotary, yeah, yours technically rotary encoders, quadrature encoders?
Yeah, I guess so.
I guess that would still be an option for me. I was thinking the induction sensors versus the quadrature encoders simply because I don't know. I don't have any reason other than um, I've got these gears on my axle that spin. There wouldn't be too terribly much difference between those and the induction sensors in the sense of I've still got stuff spinning around. I don't know. I'm just so many options. Oh, the other thing I did come across, not that you use it, but um, came across this series of linear actuators. They're a little bit, yeah, it says 1,300 pounds. Like, come on, guys. How do you figure that? Um, but I guess it's the actuator that goes in something like a hospital bed or a standing desk. I couldn't get a lot of, it had 5 millimeters a second, so it's not super, super fast. You probably understand that 6,000 N number there, but uh,
I think it's newtons, which I don't know what that means, but I think that's probably what it is.
yeah. So anyway, I thought those were an interesting a 6-inch stroke would certainly be enough. Um, but I still have some from the last linear actuator purchase, so I think I'll stick with those. But they didn't mention anything about the driver for these. I guess and it doesn't say it has feedback either. So you probably have to have some other on-off process for controlling these things. Yeah, it looks like it's just straight DC power.
Yeah, if you look around, you can buy these that have feedback built into it. So, it just depends where you get it and how much you want to pay for it and what you're trying to do with it.
Yeah, that might be some of what that's all about. I don't see enough wires for any control there. Okay. That's all I got.
I think that's all I got too.